Today we're going to look at where functions meet. In this case, we're going to have two different functions. In the diagram here, we can see we've got a quadratic and a linear function. And in the first situation, we could have the two functions cutting at 2 points. In the second situation, they could be cutting at 1 point. So it's 1 point of intersection. And in the third case, where we have no points of intersection. The word tangent you're going to come across a lot, especially when we get to calculus, and that refers to a line which cuts another function at only 1 point. So that term tangent is an important word you start to learn. So what we want to do is to be able to solve like simultaneous equations that you did in year 10, where we had two linear simultaneous equations. In this scenario, we've got a quadratic and a linear. You could also have two quadratics, and that's where the questions will get harder. What we want to do today is go through two ways of solving them. We want to look at a graphical solution and an algebraic solution. If you're in a paper 2, that's going to be the paper where you're allowed to use your calculators, then a graphical solution is a nice, easy one to do. So I'm looking at an example out of the exercises, out of exercise 1E, question 1A. You can pause the video, set this up on your calculators. When you set it up with these two functions, then you will see that we get a point of intersection, in fact 2 points of intersection. So you need to be able to go on your calculator, enter your first equation as function 1, second equation as function 2. Then if you go to, where do you think you're going to go to on your calculator? Menu, analyze graph, and in this case you're going to go to point of intersection. So now you're going to go doing that, you should come up with two solutions. So we can find the solutions for both points where it intersects. The first one is at 1, 7. So that's that coordinate point. And the second one was at 2, 8. Obviously, when you're solving with your calculator, I'll just write down here, point of intersection. Alright, you will be able to get both coordinates. If we're solving it algebraically, then what we're going to do is, this would be no calculator. So you're going to equate the equations like you did in simultaneous equations in year 10. So you'll go minus 2x plus 8 is equal to x plus 6. And you're simply going to solve those equations. Bring everything over to one side. X squared minus 3x plus 2 equals 0. Solve that with whatever method you like. You can see it easily factorizes. So x is equal to 1 or 2. So if you're after the points of intersection, that means you need both coordinates. If you're just after a solution to this original equation, then it's sufficient to give your answers as x equal to 1 or 2. If you're after the point of intersection, then you need to substitute in x equal to 1, and just like you did in your simultaneous equations, you could choose either equation. I would always pick the easiest one. Y is equal to x plus 6, y is equal to 1 plus 6, so y is equal to 7, and then do the same procedure again with x equal to 2, substitute it into there. So you get your 2 points, 1, 7, 2, 8. You can always put it back into your quadratic equation and just check that it works on that one as well. So that's solving those two equations, simultaneous equations. There are times that they will then do a further part and go, hence solve this inequality. The point of that is that you already have worked out your point of intersection between these two functions. The question is, where is this function greater than this function? And if you look at your graph, you're basically saying, where is this line, the function above the quadratic line? So we can see that in this region here, the linear equation is above the quadratic, so our solution would be in this region. And what's that region? It's the region between those 2 points of intersection. So I've just got these up because they're connected to the graph, but our solution here would be x is between 2 and 1. So that's our solution to that, if we're doing it graphically. So you could just graph it up to see that. If, however, same story, if you are in a non-calculator situation and it said the same question, hence solve this relationship, this inequality, you would go through the same procedures we did before. X squared minus 3x plus 2 is greater than 0. Factorise it. Is greater than 0. So then you can't just solve that algebraically, you still then need to go back to a graph. So that's where I would think, what does this original quadratic look like? It's concave up. I've got intercepts at 1 and 2. I'll do a quick sketch. Concave up means my curve is going to look like this. And then think, whereabouts is this function greater than 0? Whereabouts is it positive? And where is that function above the x-axis? Where is it positive? In those regions there. So then I can do my answer. So here I've got my answer, x is greater than 2 and x is less than 1. So this was a different scenario because in this case I wanted to see where was the quadratic greater than the linear, whereas the previous example I was saying when is the quadratic less than the linear. So solving it graphically or solving it algebraically. And that's it for today.